Well, hello. Today I'm working on a different project to the one I've been working on for a while. I've decided to concentrate on my birthday reminder project, which is going to be based around this ePaper display module. And the point of this project is that I'm always forgetting when people's birthdays are and special days that I'm supposed to remember. So I've tried a few times different methods, calendars on the wall, putting things in my phone, reminders and stuff like that. Nothing's ever worked. So I thought if I make a little module, use this ePaper module that I've got, and I make a display, put sort of at the top of the display something like somebody's birthday is tomorrow, the other person's birthday in 3 weeks' time, somebody else's birthday in 2 months' time, and I put this module somewhere so that I can see it, such as on the dining room windowsill. So it's continuously telling me the next 3 or 4 birthdays that are coming up. I can't fail to spot that it's somebody's birthday, and I might actually do something about it. So that's the point of the thing. And I've got this ePaper display module. So this is a 4.2 inch ePaper module, and it is from Waveshare. Let's see, can I disconnect that? Let's not disconnect it. Let's just turn it around. So that logo there is the Waveshare logo. It's a 400 by 300 pixel module. And if we can get any kind of focus at all on this thing, there we go. There's not a lot on it actually. So you've got a load of wires that go to your microcontroller, let's say an Arduino, coming in here. I don't know quite why there has to be so many. And it goes to really what just appears to be a few diodes and maybe even, what are those things, resistors? I'm not sure what all that lot is actually. A little tiny coil is that. But whatever they do, which doesn't appear to be very much, it then goes to this connector here, which then goes through to the display and displays the image that you send to it on the screen. And it's ePaper. So what is ePaper? What's the big deal about an ePaper display? Well, the main difference between an ePaper display and other displays is that it requires absolutely no power whatsoever to show the image on the display. This isn't backlit, this particular one, and all it requires is some power to change the picture that's on it. So if you want to change one of these pixels on here from light, say from white to black or from black to white, that requires power. But once you've changed them, they'll stay like that forever without any power applied. So I've got a little Arduino sketch which it keeps putting the date and the time on here just so I can see that it's actually working. But I'll demonstrate hopefully if I can get this connector off here. Let's pull this thing off. It's a bit of a it must have a little clip, mustn't it? There we go. So it's completely unplugged now. There's no power going to it at all, and yet the image stays on the display. And I think it's quite a good quality image. I've got a little bit of a shadow going across the screen here, which isn't helping massively, but I think it's quite a good quality display. A little bit low resolution because it's only 400 by 300 pixels. So if we look closely, we can see pixels on those letters, but it's actually got quite good contrast. If you've not come across ePaper displays before, they're pretty good at being read in daylight without any backlight. So as you can see, there's nothing lighting this thing apart from ambient light in the room, and yet the contrast is pretty high, and the image appears to be right on the surface of it. There's no depth to it at all, like it's under a layer of something. It is just right. It looks like it's right there on the front. It's microscopically thin, actually. Most of the thickness of it is the circuit board that it's laying on top of. I don't know if it's bendy. I think it's quite rigid. Anyway, it's sitting on there somehow. Let me just compare. What I've also got here is my Kindle Paperwhite. Here he is. The battery level is that. So this is my Paperwhite Kindle. Let's see if I can zoom the text on this. Now, the other thing about ePaper displays that's worth mentioning is they're pathetically slow to do anything. They up, they down, they change. Nothing goes fast on a Kindle. Nothing goes fast at all. So like when you scroll from one page to the other, it's pretty slow. Look, I'm increasing the font size here, and it's, I don't know, I get that and put that on like that. There we go, that's probably a little bit too much. So I'm just trying to get something that's vaguely similar to the image that's on here. So if we look at the Kindle display and this display that I've bought off eBay, they're actually reasonably comparable. Now there's a little trick though, because of course the Kindle Paperwhite is backlit. So let's see if we can turn off backlighting. Let's get a true comparison. Right, so that's a true comparison now. That's backlighting's off on the Kindle. There's no backlighting on this module, and I've got to say, apart from the Kindle having a much higher resolution, possibly the WaveShare ones maybe even got a slightly higher contrast. Or maybe not. Anyway, that was just a comparison of Kindle versus eInk, ePaper, what do they call it? 4.2-inch ePaper module. Now I noticed that there are quite a few of these on Amazon. Let me see, Amazon, eBay. So if I just click here on eBay, here's the one that I got. Now it says it's £40. I can't believe that I paid £40 for it. I bought this several months ago, actually, probably at least 6 months ago. There's no way I would have paid £40 for it. So I obviously didn't buy it from UK Salesmaster, did I? Where's that coming from? It's coming from the UK, that's why that was quite expensive. I bought mine from China without any doubt, and but it's exactly the same one. And they have, these WaveShare people have quite a few displays. And I noticed that some of them have got some of them are just look, there's a 5-inch one, for example. The 5-inch ones I noticed had a lot more. It appears to have a microcontroller on the back of that one, doesn't it? Look, that's 800 by 480. That's quite a good resolution, and it's got a microcontroller and a USB port. It's a bit more of a big deal, actually. It's a bit. It's not. It's just. That's funny. There's no way I paid £40 for mine, because look, that one there, for a much better one, is only £47. So, well, when I say only, I still think that's pretty expensive. But anyway, my point is, this one that I've got here has very little electronics on the back. All the brain has to be done by the Arduino, which I'm coming to realise is a little bit of a mistake, and I probably should have got the one with a bit more brain power on board, because it means the Arduino has to do all the work. Now, if I can put this connector back in up the right way, did it go that way? Look, it's worth pointing out as well, if we can just get that into focus, that this is a 3.3 volt piece of kit. 3.3 volts being the bottom pin, so that'll be red, so that'll be there. Go in there, and what I've done is I've rigged up. Oh look, now it's back working again. I've rigged up an Arduino just to send the current time to it. So is it really 12:57? It is, so the current time is correct. You might notice that it flashes several. Sorry, it's not in focus. It flashes several times when it's updating the display, which is just horrible. But for the project that I'm doing, I don't think that's going to matter too much. So let's just go over the concept of what I've got here. I've got also, I might pull these bits apart so you can see them. Yeah, let's do that. Well, I'll show you what I've got rigged up so far. There's just as kind of a, just sort of doodling around, seeing if this thing is even going to be possible. I've got here a real-time clock module, battery backup, a battery backed up real-time clock module. There are thousands of these on eBay. This one I think is called something like a what does it say? ZS042. ZS042 battery backup real-time clock module. And the point about it is, you set the time and the date in here. It knows what day and time it is. It counts up, and even when the power's off, this little battery here, this is a CR2032, so a non-rechargeable battery, that keeps it going. Now, I've just found one on eBay here, and this is about right, look, 99p. It shows it without a battery on it, but mine came with a rechargeable lithium cell on it, and I bought it about 2 years ago. I left it laying around, didn't touch it. The cell discharged right down to 0 volts and has never worked again. So then I thought, oh well, I'll just stick a CR2032 in it, and they're not rechargeable. This board does recharge whatever battery is put into it, which would of course kill a non-rechargeable battery, because this CR2032 is not a rechargeable battery. So I looked online somewhere, someone said if you take out a little resistor that's just here in the top right corner, it breaks the charging circuit, and then a normal battery can be used in it instead of a rechargeable battery, because I didn't have a rechargeable coin cell like that. And so then when power is applied, it runs off power. Look, power is applied at the moment, that's why that little LED's on. When it's not on power, the battery will keep the clock running, and it keeps really good time actually. So it must have somewhere on board, where is it going to be? It must have an oscillator on board, mustn't it? It must have they used to have a 32.768 crystal on there somewhere. Which one of those components is that? It's not that thing, because it's a diode. Maybe it's underneath the battery. I don't know. Maybe it's built. It's probably built into the chip actually. Now I think about it, it's probably built into the chip. So that knows what time it is. This can show things on the screen. I also need something to store people's birthdays or their date of birth or whatever, and read the time off of the real-time clock module, work out whose birthdays are coming up next. Just reading the date off of the real-time clock module, to be completely honest with you. And I realised once a day, update the display to say it's Dave's birthday tomorrow, it's Amanda's birthday on Thursday. And the reason I only need to update it once a day is because, of course, birthdays last an entire day. So you only need to change the display once a day, which is why I thought the ePaper display would be the best, because it means that all day, so for basically 23 hours, 59 minutes and 59 seconds of the day, it can be completely powered off, and it only needs to be switched on, probably on the stroke of midnight, switched on, work out whose birthdays to display, update the screen with a new set of birthdays, and switch off again and sleep until the middle of the next night, and do the whole thing again. The brains behind this, I've got it all wired up with in the classic rat's nest style. So the brains behind all this at the moment is this Arduino here. I'll just cover that bit up for a moment because it's confusing. So this is an Arduino Pro Mini, isn't it? This is an Arduino Pro Mini. Let's see, can you see that? Arduino Pro Mini. Codename The Simple. Don't know why, but it is codenamed The Simple. It's a clone of some Arduino or other. Well, it's a clone of an Arduino Pro Mini. And it's at 3 volts as well, 3.3 volts as well. So the display is 3.3 volts, the real-time clock module runs at 3.3 volts, and the Arduino Pro Mini runs at 3.3 volts. I'm supposed to be covering this bit, so don't confuse you. This bit is just the programmer, because, let me go like that, because the Arduino Pro Mini doesn't have a USB interface on it. It comes with just sort of 1, 2, 3, 4, 6 holes down the side, which I've soldered a connector onto, and so you need one of these, which is it's an FTDI serial. What is it? USB to USB. It's a USB converter, an FTDI USB converter for programming Arduinos that don't have a built-in USB port. So hold on, let me get a normal USB. Let me stop waffling and get a normal Arduino. That would help. That'll clarify matters. So here's an ordinary Arduino. This is the first Arduino I ever bought. Actually, it's pretty old. Look, it's got a real chip on it, and it's got a USB socket. In fact, ye olde original USB socket the size of Russia on there. So that thing means that you can plug your computer. Well, not with this USB plug you can't, but if you had an old school one that you only see on printers, you can plug that in there and your computer can talk straight to the Arduino over USB. But the Arduino Pro Mini is, well, the point of this is convenience. The point of this is simplicity. That's probably why it's called the Simple. So it doesn't have a USB connector. It just comes with 6 small holes, and so it's basically skipped the USB adapter altogether and gone straight for a serial connection to the chip to program it. So you have to get a little programmer. I think these cost £2 or something. This one is an HW417. So this is these are totally ubiquitous. This one has the feature that it can do 3.3 volts and 5 volts. I've got it switched to 3.3 volt mode, but I discovered when I forgot to switch it to 3.3 volt mode that it didn't kill the Arduino anyway, so it wasn't too important. So I soldered a connector on there. Stupidly, I soldered a socket on there. I should have soldered pins on there and made an adapter, I think, in retrospect, but that's what I did. So that means that goes in there. You plug your USB in here. Something keeps short-circuiting on this as well, which is upsetting my computer's USB port. So I have to be a little bit careful when I do this. I don't know if it's a cheap socket or whether the pin's a bit wonky. But anyway, that goes in there. And the whole thing's going nicely. So when you want to program this Arduino, you use the Arduino IDE. Well, what I use is the Arduino IDE on my computer. Talks over USB through this adapter and programs the Arduino Pro Mini. I'm not sure whether it's worth all the bother, but I'm figuring that because it doesn't have a USB connector, it's going to draw less power than an ordinary Arduino. Certainly it will draw less power than this bad boy, but it will probably even draw less power than an Arduino Nano. Have I got an Arduino Nano? No. I must have. I live on Arduino Nanos. I've got thousands of them. Yep, here we go. So this is for comparison. There's an Arduino Nano. What have they done there then? Why are they wasting space down the end? Oh, because the regulator's on the back. There's actually nothing on the back of the Simple. But on this Nano, the regulator, voltage regulator, and the USB to serial chip is on the back. So you've got effectively exactly the same chip, exactly the same reset button by looks things, but they've taken the circuitry for the, in fact they put the regulator on the front there, a really tiny one. They've taken what circuitry would be there for the USB and they've removed it. So you get a slightly smaller board, presumably less current being drawn by that thing, and it's 3.3 volts. I think you can get 5 volt ones. I'm not totally clear what the distinction is because these Atmel chips can run on loads of different voltages. But it's a 3.3 volt version. Maybe it's got a 3.3 volt regulator on it. Not sure. And I'm figuring it's going to be quite low power. And why I keep wittering on about 3.3 volts and low power is because I want to power the whole thing by this lithium battery that I bought. So this is, I think this cost about a £5 lithium battery that I got off eBay, and the camera hates it. There you go, that's better. The camera didn't like that, did it? I think it's too shiny. And this claims to be a 4,000 milliamp hour, 3.7 volts battery. Are they real milliamp hours or are they fake, cheap eBay milliamp hours? We don't know. But it's quite chunky, actually. Look at the thickness there. It's not the thinnest battery you can get, in fact. It looks like it's possibly a few batteries glued together, doesn't it? It's got a little bit of this stuff on the top here, which I've discovered is called Kapton tape. I used to think it was called Kapton tape, but it's Kapton. I think, possibly, is there some circuitry there to control over voltage, under voltage, or is that just a piece of board. Not really very clear. But what I've done here is I've got hold of some lithium battery chargers. These are real cheapo lithium battery chargers. These things are almost literally 10 a penny. And what it does is it's a USB charger for lithium batteries. There's the USB socket there. You connect your battery up there, and it just looks after the battery. Make sure you don't overcharge it. Make sure it doesn't undercharge, because lithium batteries are damaged by going above and below a certain voltage. And it outputs the output on these two wires here, which I've put a bit of tape over so I don't actually accidentally short them out. So this, I think, these are all the components for my project. So we're going to have Arduino as the brains, battery to keep the thing going, USB socket to charge the battery when it goes flat, real-time clock module so that it knows what time of day it is, display to show the results on the screen so you can see what's going on. And my goal is to use this real-time clock module. So I discovered it has an alarm feature, so you can set an alarm. So I'll set the alarm for something like 1 second past midnight, and it's not an alarm that goes beep beep beep. It's an alarm that sends a little pulse out of this one of these two pins. I think the SQW pin, I'm guessing. I think a pulse comes out of that pin when the alarm goes off. So if I set it for 1 second past midnight to send a pulse, the pulse can then come to the Arduino, tell the Arduino it's time to go. And the Arduino will consult the real-time clock module, find out what time it is, look up in its little memory to see whose birthday it is, construct some birthday reminder messages, put them on this screen. So update the screen with that nice flashy flash, update the screen thingy, which you won't see anyway because it will be 1 minute past midnight and you'll be in bed. And then the whole thing will go into some sort of sleep mode, some sort of micro low voltage, low current mode. So basically drawing the absolute minimum amount of current I can possibly persuade it to draw, sleep for almost an entire day, and then get woken up again the next night and repeat the same process. Well, that's the theory.